Good morning. Today we are going to cover circles. Circles is the last conic section that we need to cover. We cover parabolas, ellipses, and hyperbolas. Circles is briefly mentioned in 10.2 as they introduce the conic sections. And you actually probably worked out some of the problems on ellipses, but we haven't formally introduced the equation and some of the properties. So a circle is a set of all points in a plane that are equidistant from a fixed point, which is your center, which is your H and K. And we talked about the definitions that we're using for conic sections, which is the locus or the collection of all the points. In this case, a circle is made up of all the points that are so many units away from the center. In this case, let's assume that this was 3 units. So all the points that are 3 units away from the circle, if we collect them, all of them, or from the center, if we collect all the points, that will make a circle. This is the standard form of a circle, where we have H and K, and that will be your center, and your radius is R. But let's go through the first example. Example number 1. I'm going to make a x and y axis. And I just need to do a 5 by 5. Now, in order to be able to graph it, I need to be able to find my center and the radius. My center is given by H and K. So in this case, my center will be positive 2, and there's no H, so it'll be 0. If there's no K, so it'll be 0. According to our equation, this is R squared. So R squared is equal to 14. Therefore, R is equal to the square of 14. And to graph it, I need to convert into a decimal. So I know that the square root of 14 is between 3 and 4. And we can estimate it to be 3.7, or you can just calculate the exact value or an approximation, which is 3.7. So my center is 2, 0. And all the points are 3.7 units. So I'll go 1, 2, 3.7, 1, 2, 3.7, 3.7, 3.7. And then I just make a proper circle. Or almost perfect. Make sure that you label your center, and your radius is 3.7. So the circles are the easiest ones to graph out of all the conic sections. Example number 2. So I need to be able to find the standard form of a circle, the standard form of the equation of a circle, and determine where the center is. So therefore, that'll be your H and K. I know the standard form of a circle is x squared plus y squared is equal to your radius. So therefore, H is 2, that'll be minus 2. K is positive 3. And they don't give me a radius. Now, if I make a quick sketch of the information that's given to me, My center is at 2, negative 3. And I know that it passes through a point 3, 1. So this is my radius. So I need to be able to decide how can I find the length of it. So one way, if you want to use your distance formula, you can find the distance between those 2 points. But since I already have the formula here, and I know that it goes through the point 3, 1, then I can just plug in the x and y value and solve for r. So therefore that will give me 3 for the x minus 2 squared plus y will be 1 plus 3 squared equal to r squared. That gives me 1 squared, which is 1, 4 squared, which will be 16, and that gives me 17 equal to r squared. Now I can solve for r, but I actually need, r will be the square of 17, but I actually need r squared to be plugged in here. So now I can just plug in the value of r squared. Problem number 3. And we've done problem number 3, something similar before, where we need to rewrite it in standard form. The only difference is that now we have a circle. So go and try it and see what we get, and then we can compare our answers. So go and pause it. Great. So now I'm going to group my x's together, leave some space, group my y's together, leave some space, and move my 4 to the right, becomes a positive 4. So that will be x squared minus 10x, leave some space, plus y squared plus 6y, leave some space, is equal to positive 4. And I'm going to complete my square twice. Notice that in this case, nothing to factor out. It's ready to be completed square. Half of negative 10 is negative 5. Square is 25. Half of 6 is 3. Square gives me 9. So therefore, factor this out. It should always be the same. So it'll be x minus 5 squared. Plus, factor this out. Y plus 3 and y plus 3, or y plus 3 squared. And that will give me 29. Plus 4 will be, plus 9 will be 38. Now I can find, this is my standard form. Now I can find my radius to be r is equal to the square of 38. And I can find my center, which is 5 and negative 3. Now there are different ways of being able to identify what type of conic sections we have. So I need to be able to identify, on example number 4, which you guys have, I need to identify whether this equation is a parabola, hyperbola, or ellipse, or a circle. And the book on section 10.5, when they cover hyperbolas, they also have a section of classifying conic sections, and where they use they compare the values of A and C to determine what type of conic sections it is. There's some other books that use something that they call the discriminant to determine what type of conic sections they are, and this is on 10.5. I prefer to do it in a more visual manner, and I use this flowchart to determine the type of conic section we have. So whenever you are evaluating, you are going to be looking at the ones that are being squared, the terms that are being squared. For example, letter A, your x is being squared and the y. The other ones are going to help you shape the conic sections, but it's not going to tell you what they are. So first, you start here, and I say, are they both squares? Yes, the x and the y are being squared. So you continue on. Do they have the same sign? No, one of them is positive, the other one is negative, so therefore that is a hyperbola. For letter B, you want to be able to concentrate on the ones that are being squared. In this case, your x and your y. So you start. Are they both being squared? Yes. So I continue. Do they have the same sign? Are they both positive or both negative? In this case, yes, they're both positive, so you continue on. Do they have the same coefficient? Yes, they both have a coefficient of 1. So therefore, that is a circle. If they have different coefficients, then there'll be an ellipse. But this is a circle. Let's do C and D together. Concentrate on the ones that are being squared. So in this case, only your y is being squared. Are both being squared, the x and the y? No, only the y. So therefore, that's a parabola. Parabolas have only one of them squared, the x or the y. Letter D. Only the ones that are being squared is what we need to focus on. Are they both being squared? Yes. Do they have the same sign? Yes, they both are positive. Do you have the same coefficient? No, they have different. So this is an ellipse. So try E, F, G, and H, and then we can compare our answers. Go and pause it. Great. So for letter E, are they both being squared? No, only the x. So that's a parabola. Letter F, they both squares. They have the same sign, but different coefficients, so that's an ellipse. Letter G, they both squared. They have the same sign. They have the same coefficient, so that's a circle. Letter H, they both squared, yes. Do they have the same sign? No, that's a hyperbola. So have a great day. Your sub will give you guys your homework. And I'll see you guys next time. Have a great day.